Hello everyone, welcome to this discussion. This is a question under 3, and we have a question that says determine the values of cos theta and tan theta if sin theta is equal to m over n, and this is simply a negative fraction. Okay, so this is our problem. Now we know to say this should be our guide in terms of finding these functions, which are expressed as ratios of the sides of a right angle triangle. Now sine itself is equals to m over n based on what we've been given, and this means that our m is the opposite from what we know. N is simply the hypotenuse. So based on what we want to find in the question, we're supposed to find tan and cos, where our sine is simply having a ratio which is a negative. Okay, now what we know is that sine is negative in third and in the fourth quadrant. So we're going to draw this like that. Okay, so we know that sine is negative in the third and also in the fourth quadrant. So we're going to find the values of cos and sine from the values of tan and cos in the same particular quadrants where sine is negative. So I'm going to draw another diagram which represents the quadrants. So do this. Okay, then I'm going to draw triangles from the third, in the third and in the fourth quadrant, where we have that sine is negative. So this is what we have, and also that's what we get in the fourth quadrant. And this is simply our angle theta here from the origin, and also our angle theta here. Now looking at what sine is, that's our right angle there. Sine is opposite over hypotenuse, of which our m is the opposite. So this side simply represents the distance, which is m, and the hypotenuse n will be this longest side of this right angle triangle, which is this. And this happens to be the same case also in the fourth quadrant. We have m here and n. Now for both cases, you notice to say there's a side which is not given, and that is the side which we call as the adjacent, where both this angle theta and the right angle lie. So we need to know this side. Okay, so to do this, we're going to use the concept of the Pythagoras theorem, which we simply have as a squared plus b squared is equal to c squared. Okay, so we will let a to be the adjacent, b the opposite, c the hypotenuse. So we don't know what a is, so we just write it where it is. Then plus our b, which is the opposite, is m, and since our b squared, so we're going to have m squared equals to c squared, to give us n squared. Now we don't know what the adjacent is, which is represented by a, so a squared will be equals to n squared minus m squared. So we'll square root both sides, and since this is distance, we want to get the positive value, so the square goes. Our adjacent is therefore the root of n squared minus m squared. So we'll do substitution on these unknown sides. We now know what it is, and this is the root of n squared minus m squared. Okay, so now since all the sides are given, let's consider for the third quadrant. Okay, so we want to find cos and tan. Okay, so I will start with cos. So cos theta, as we know, it is simply the adjacent divided by the hypotenuse. Now from our findings, we have the adjacent to be the root of n squared minus m squared. So we make a substitution there, there's adjacent, hence cos theta equal to square root of n squared minus m squared, then over the hypotenuse, which is m, from what we have, n, sorry. Then now let's find tan. So tan theta, which is known to be the opposite over the adjacent. So tan theta is equal to the opposite. We have it as m. Then the adjacent is simply the root of n squared minus m squared. Hence we have our two ratios, sine and cos, in that manner. Let's look at the fourth quadrant. Now for the fourth quadrant, since everything is just the same, like in terms of sides and all that, we just get the same values for that we have in the third quadrant. So for the fourth, we also get the same as what we have in the third quadrant, which gives us our cos to be n squared minus m squared under a root divided by n. Then we come to tan theta, which will just also be m over the root of n squared minus m squared as what we have in the third.